Today we're going to add and subtract some rational functions. So again, a rational function is just when you have some expression divided by another expression. This gives you a rational function because you can write it as a fraction, basically. I mean, you could argue that x squared is a rational function by itself because you could write it as x squared over 1. So just be aware that lots of different kinds of functions fit into this category. So we're going to be adding and subtracting them, and all we're going to be doing is using our normal rules of fractions to be able to apply this. I'd say a key thing going on is like if you have, say, a third plus a quarter, then what do? We make the denominator 12. We multiply the top and bottom of a third by 4. We multiply the top and bottom of a quarter by 3, and then we can get 7 over 12. Brilliant. However, what if we had something like 1 over 8 plus a half? Now you could do the same method we just did, but much better to look for the lowest common multiple. And actually, whilst the lowest common multiple of 3 and 4 is 12, the lowest common multiple for 8 and 2 is 8. So keep that 1 over 8 the same, and then just change the half to 4 over 8. And then we get 5 over 8. This is going to be really, really important later on. So make sure you've got your head around that. Hopefully when you got taught fractions, you got taught to do that, not just to basically multiply the denominators together. This is a better method. It is. Okay, let's add some algebraic fractions. So we're going to do this in exactly the same way. And as before, it'd be really great if you could just pause the video, have a go at doing it, and maybe you can skip through my explanation if you can already do it. I just want to make sure that everyone's practicing it. It might have been a while since you've added and subtracted fractions like this, and they're going to get a bit trickier, hopefully to ones that you've not done before, but using the principles that we know, we can practice them and master those as well. Okay. So in this fraction here, what am I going to do? I want to make the denominators the same, so I'm just going to multiply top and bottom of the first one by 3 to give me 3 over 3x, and then for the second one, I'm going to multiply top and bottom by x to give me 2x over 3x. That means I can write it as 3 minus 2x over 3x, and that's my answer. Second one. Similar sort of thing. The lowest common multiple is actually going to be these two multiplied together. So it's going to be 3, and then I want to multiply top and bottom by 2x plus 1. Then this is going to become x plus 2, 2x plus 1. And then I'm going to be minusing. Okay, I'm just going to remove this. As important as this is, it's just going to get shifted away slightly up here. And then the second one, I've got 6, and now I'm going to multiply top and bottom by x plus 2. We're just using equivalent fractions. Okay, now the denominator is the same. I can just add them together, and subtract the numerators in this case. Okay, and we've constructed a single fraction. Brilliant. We're not quite finished because we need to expand out the brackets. So we're going to get 6x plus 3 minus 6x minus 12 all over the same thing. I'm not going to bother writing it down again. And that's going to give us, the 6x is going to cancel, so I'm going to be left with minus 9 all over x plus 2, 2x plus 1. And that's our answer. It says simplest form. I would leave the bottom factorized. It doesn't make it simpler to expand it out, although sometimes you do say expand and simplify. But in this case, it's more useful to have it factorized. And if we were solving an equation such as this is equal to 3, actually, we probably would end up expanding it. But it's fine to leave it factorized. That's what I'm trying to say. Okay, next one. Just going to shift these up. Okay, now I'm back to where I was talking about x or x squared being a rational function, x is a rational function, we can write it as x over 1. So how can I write this as a single fraction? Well, I need the denominators to be the same, so I'm going to need to multiply x by x plus 1 and divide it by x plus 1 at the same time. This is going to become x plus 1 minus 1 over x plus 1. Expand this out, I'm going to get x squared plus x minus 1 over x plus 1. And that's our answer again. We can't factorize the top, it's not going to cancel at all. That's as far as we can go. Quite interesting that we can, that these two are the same thing. Later on, we're going to start with expressions like this, and I could ask you to say integrate this, and it looks horrendous, but actually you want to go the other way. You want to actually write it like this and then integrate that, because we know how to integrate x. We will be learning how to integrate 1 over x plus 1, whereas this one here is slightly horrible. So I'm just getting ahead of ourselves a little bit, but being able to go to the right is useful, being able to go to the left is useful. You might want to think about how to go from this thing on the right to the left. I don't think I'm going to talk about it now. All right, 2 more. Again, try them if you like, and this is where this the lowest common multiple starts coming in, because the worst thing that you could do here would be to multiply the top and bottom of this by x plus 2 and the top and bottom of this by 2x squared plus 3x minus 2. You're going to get a cubic on the bottom. It's just a really, really bad idea. You might sometimes have to do that, but let's try and see actually if the lowest common multiple is smaller than these two multiplied together. And to do that, we are going to factorize the bottom. So basically, whenever you start getting a quadratic in the bottom on the denominator, or anywhere to be honest, see if it, whoops, I missed out the x here. See if it factorizes. Okay, I'm going to use this method where we just try some values, because we've got 2x, so all it can be is 2x and x, and I've got a small number here, minus 2, so one of them is going to be negative, one of them is going to be positive. Let's try a plus 2 here and a minus 1 here. That's going to give me 4x, and a minus x, that's going to work. And hey presto, we do actually have an x plus 2 in there. So I hope you can now see why we should do this. So I'm going to now write the same thing again, 31x minus 8 divided by 2x minus 1 x plus 2. Okay, I can now do basically what I did when I was adding eighths. I only need to multiply the half by 4 over 4. Here I just need to multiply this fraction by 2x minus 1 over 2x minus 1. So it's going to become 14 2x minus 1, and then I've got 2x minus 1 x plus 2 on the bottom. Okay, now I can bring it all together. 31x minus 8 minus 28x, and then I'm going to get a minus 14 with another minus. It's going to become plus 14. Right, bit more to do. This is going to become 3x plus 6 all over 2x minus 1 x plus 2. Are we finished? Well, we should probably just factorize the top and see if there are any common factors in there. So we could take out a 3, and wow, we're left with an x plus 2. So actually, this is not the final answer. I can now cancel out the x plus 2's, and my final answer is simply 3 over, oh, I don't need the bracket, 3 over 2x minus 1. So I guess this is another little hint. As well as this first hint, try and factorize quadratics. At the end, always look to see if there are common factors in there, especially yeah, when you have sort of a quadratic that's been factorized, and that's another reason why we shouldn't expand the denominator, because we wouldn't have been able to spot quite so easily that these two are going to cancel. But this fairly, complicated pair of rational functions that we're subtracting simplifies to quite a simple thing. Okay, like that one a lot. All right, one more. What happens if we've got three of them going on? By now, you'll know definitely don't just multiply all these denominators together and deal with that. Like don't multiply this by x squared minus 7x plus 10 and x minus 5. You're going to get some sort of quartic on the bottom, an x to the 4 function. That's not a good idea, is it? Instead, let's try and factorize the quadratic to see what happens. So I'm not going to write the whole thing out. I'm just going to try and factorize this. I'm going to get x and x, and then I know that I've got a negative here and a positive here, so they're both going to be negative. It can only be minus 2 and minus 5. Oh look, exactly the same as what we've got here. So I can just be a bit smarter. I can write my lowest common multiple. You can write this by the side if you want. The lowest common multiple is actually going to be x minus 2, x minus 5. So for the left-hand one, multiply top and bottom by x minus 5. I think it pays to show you working, sufficient work, and just be careful. And then this is going to stay the same, 3x plus 1 over my factorized expression. And this one I'm also minusing, so I'm going to multiply top and bottom by x minus 2. Bring it all together. I'm not going to expand my brackets quite yet. You need to be a bit careful with these negatives. So I'm actually minusing all of 3x plus 1. It would just be wrong if you didn't put those brackets in, because actually you need to be also minusing the 1 through, and you get that by including this bracket. And then we're going to be minusing x minus 2. I'm just going to say that one more time. Make sure you put brackets in when you're dealing with these sorts of fractions. Okay, the bottom stays as x minus 2, x minus 5. Now we expand it out. We're going to get 2x minus 10 minus 3x minus 1 minus x plus 2, all over the same thing. I'm not going to write it all out again. Okay, what's going to happen now? We've got 2x, we've got minus 3x, we've got minus x. That's going to give us minus 2x. And I've got minus 10, minus 1, that's minus 11, plus 2 is going to be minus 9 over x minus 2, x minus 5. In this case, I can see it's going to be no common factor. I could take a minus 2 out, but I'm going to get it's going to get 4.5 here. So that is our answer. That is our lesson on adding and subtracting rational functions. Just one thing to say again, just look for the lowest common multiple, not just multiplying the denominators together. Especially important when I just can't imagine even trying to do this question by multiplying all the denominators together. So practice this, make sure you're happy with it. It's just practicing your algebraic skills, ready for more complicated maths ahead.